Hello everyone, and welcome back to another video. Now, this video is going to be on the Fundamental Theorem of Calculus. Now, why haven't I explained that already? That seems like it would be kind of an important thing to do if it's so fundamental. And the reason why is because I assumed it was self-explanatory enough that if you're already taking a calculus course that you would not need a video on it. However, people that I know have been asking me to do it because they have been getting tests and quizzes with questions that relate to it, but build upon it to make questions that are much harder. So I'll talk about what it is exactly, but then I'll start diving into how it can be used to find more complicated information and answer more complicated questions. This is what the Fundamental Theorem of Calculus states. Given the integral from a to b of some function of x with respect to x, this will equal, this capital F represents the antiderivative of the function f of x. For example, the antiderivative of 1 over x would be ln x. The antiderivative of x squared would be 1/3 x cubed. These are things that you've seen already in my videos so far, so hopefully you can understand the concept of what an antiderivative is. It's just a function where if you take the derivative of that, you'll get back to the original function. Okay, so we understand that. And this by itself, I mean, if it was just this, I wouldn't be making a video on it. It's just a single formula, and it's pretty dang easy to remember. However, let's talk about taking the derivative of an integral like this and what that looks like because of this. What I mean by that is let's look at a function g of x is equal to the integral from 0 to x of some function of t with respect to t. Now we have two different variables. This might be a little complicated to think about at first, but really what it's saying is that g of x is equal to the antiderivative of f evaluated at x minus the antiderivative evaluated at 0. This, of course, comes from the Fundamental Theorem of Calculus. Okay. Now, this is the problem that a lot of the students that were asking for my help comes from. What happens if you have the derivative of g of x? G prime of x. Okay, well, let's look at this side. For one, the antiderivative of 0, no matter what the antiderivative function is, when it's evaluated at 0, it will always return a constant. If you put in a constant, that's the definition of a function. If it has an input, then it must have an output. So we know that this will be constant, and when we take the derivative, it'll just go away. We don't have to worry about it. Now, this is the antiderivative of f of x. Since we're differentiating both sides with respect to x, we know that this is the antiderivative of f. Taking the derivative of an antiderivative will give us the original function back. Okay, so as we see, if g of x is equal to the integral from 0 to x of f of t dt, the derivative of g of x is equal to this inside function of x, just f of x. Now, this is going to be something worth note. Let's say instead of 0, it was a. Just any real number a. How are we supposed to know what the derivative of g looks like now? It's actually the exact same. Since a is a constant, the antiderivative evaluated at a will always be a constant, and taking the derivative will always result in it going to 0. And so, if this is any constant at all going to x, then you have g prime of x is equal to just the function on the inside, f of x. I've also seen some classmates have questions like this, where instead of just a to x, it'll go to a from a to x squared. Now, this is clearly not the same thing, and we can't just say that the derivative of g is the inside anymore. But what is it? Well, g prime of x, we know that this will, because of the Fundamental Theorem of Calculus, will have the antiderivative of f evaluated at x squared, and minus the antiderivative at a will always be constant, so when we take the derivative, we won't worry about that. What I mean to say is, the derivative of g will look like the derivative of the antiderivative of f evaluated at x squared. What does that look like? Well, the antiderivative will go away, and we'll just have f of x squared. But now we employ the chain rule. Since we differentiated a function, and the input is not just the variable that we're differentiating with respect to, we are going to have to multiply by the derivative of the inside. The derivative of x squared with respect to x is, of course, 2x. And of course, it doesn't matter what a is as long as it's any constant. Okay, let's use these concepts to do a practice problem real quick, and then I'll send you on your way. Okay, let's consider this problem. We describe g of x as the integral from 1 to the square root of x of the square root of t squared plus 9 dt. And we're looking for g prime of 16, so the derivative evaluated at x equals 16. We could find an expression for the derivative by solving the antiderivative of this, plugging in, and then taking the derivative of that, but that sucks. Let's not do that. Instead, let's use the fundamental theorem of calculus. Let's begin by trying to find an expression for g prime of x. We know that g of x is going to equal, we'll call this whole thing just f of t for now. F of t is equal to square root of t squared plus 9, all right? Now, the antiderivative of that is going to be capital F. And we're going to evaluate that at the square root of x minus capital F evaluated at 1, because we're going from 1 to square root of x. Now, g prime of x, this is a constant, and it'll go away. Capital F of square root of x. We know the capital F will become lowercase f. It's the antiderivative, and we're differentiating. So it's going to go back to normal f, evaluated still at square root of x. Chain rule. What's the derivative of the square root of x? As a reminder, square root of x is equal to x to the 1/2. Now, if we bring the power down and then subtract 1, that's just the power rule, you should know this, we'll get 1/2 x to the negative 1/2. What that looks like is 1 over 2 root x. So this is our expression for g prime of x. Now, let's plug in the 16. Doing that, we will find this equation. 1 over 2 root 16 times f of root 16. All right, let's try and figure this out. 1 over 2 root 16, well, root 16 is just going to be 4, and then 4 times 2 is 8. So we're going to have 1/8, and then that's going to be multiplied by this function. What is this function? Well, it's just this function up here. If we plug in square root of 16 into this t, well, square root of 16, and then we'll square it, so that'll just cancel, and we're left with 16. 16 plus 9 is going to be 25, and then there's still this square root on the outside to take care of, so the square root of 25, which is, of course, 5. 1/8 times 5 is, of course, just 5/8, and this is going to be our final answer. G prime of 16 is equal to 5 over 8. Now, hopefully you're able to understand the fundamental theorem of calculus now, especially its applications in making questions like this much, much easier to figure out rather than having to actually evaluate this integral and then retake the derivative. I hope you learned something by watching this video, and thank you so much for watching.